This question is about complete combustion of hydrocarbon. There are three types of hydrocarbons: alkanes, alkenes, and alkynes. Now, any type of this hydrocarbon, when they are completely combusted in excess oxygen, all the carbon will turn into CO2 and all the hydrogens will turn into water. So this will be x, this will be y over 2. Now in this question, they give us the mass of carbon dioxide and also the mass of water. Now since all carbon in the hydrocarbon will turn into CO2, so the number of mole of CO2 that is produced will give us the number of moles of carbon in the hydrocarbon. In this case would be Q. So since we are given the mass, so divide the mass by the molar mass of CO2, which is 12.0 plus 16.0 multiplied by 2. Okay, if we use the calculator, it will be 0.08 mole. So now, the number of moles of water will give us 2 times the number of moles of H in hydrocarbon, right? Because one molecule of water contains 2 hydrogen. So this multiplied by 2 will give us the number of moles of hydrogen in hydrocarbon Q. So 1.44 gram divided by the molar mass of water, okay, which is divided by 18, will give us 0.16. Now let me find the ratio of number of mole carbon to the number of mole of H. So 0.08 to 0.16. Now to get the simplest ratio, we multiply these two values with the smaller one among them, which is 0.08 in this case. That will give us 1 to 2. Now, what do we do with this ratio? This ratio will help us to get the empirical formula of the hydrocarbon, which is CH2, 1C, 2H. Now let's look at the answers. We have A, B, C, and D. Let's look at compound A first. It has 1, 2, 3, 4, 5, 6 carbon. And each carbon is bonded to one hydrogen. That would be 6 hydrogen, C6H6. So this gives us the CH2 CH empirical formula. CH. So A is not hydrocarbon Q. Now let's look at B. It has 1, 2, 3, 4, 5, 6, 7, 8. 8 carbon. Now let's count the number of hydrogen. 1 hydrogen, 2 hydrogen. Okay, another 2, another 2, another 2, 2, 2, 2, and last 2. So altogether 16 hydrogen. That gives us empirical formula CH2, which is the same as the empirical formula that we have found just now. So B is the answer. Now let's just go through C and D also. C has 1, 2, 3, 4 carbon. C4, 2 hydrogen. H2. That gives us empirical formula of C2H, which is not the same as the empirical formula that we found just now. Now the last one, compound D. 1, 2, 3, 4, 5, 6 carbon. Let's count the number of hydrogen now. 1 hydrogen, 2 hydrogen, 4 hydrogen, 6 hydrogen, 8 hydrogen, and 10 hydrogen. Okay, let's simplify this. We found that the empirical formula is C3H5. Okay, it's not the same as the empirical that we found just now. So we confirm that the answer to this question is B.